A galvanometer gives full-scale deflection with current Ig. Can it be converted into a meter of range I less than Ig? So we have this case, okay? Ig. This is maximum current that can be passed through the galvanometer, okay? And the current Ig produces full scale deflection in the galvanometer. Now let us discuss the basic theory, okay? That is conversion of galvanometer into ammeter, and then we will discuss this question, okay? So I'm writing conversion of galvanometer into ammeter. So let us discuss this. We know ammeter, it is connected, or it is used for, let's say this, it is used for measuring current in the circuit and is connected, okay? This is connected, always connected in series only, and resistance of ammeter, okay? Resistance of ammeter must be very low, that is negligible. It must have very low or negligible resistance. So we find this, okay? So we have this. Now we want to change galvanometer into ammeter. So we have galvanometer, okay? Now maximum current that can pass through the galvanometer is Ig, and we want to change this galvanometer into ammeter, okay, which can measure current greater than Ig. So I'm writing in this way. Let I be the current in the circuit, okay? Let I be the current in the circuit which is greater than Ig. So we have this, okay? So we are discussing theory right now. Now this galvanometer is not suitable for measuring current I. Why? Because the needle will be out of scale. So it is not suitable for measuring current I in the circuit. Therefore, a low resistance called shunt S is connected in parallel with the galvanometer. So let us connect a low resistance called shunt. So this is shunt connected in parallel with the galvanometer. Now this is point A, okay? Let us call this as point B. So what we find, we have I current. So I current at point A will divide into two parts. One, current IG galvanometer, and this is the maximum current galvanometer which causes maximum deflection, and remaining current I minus IG flows through shunt. So we find this, okay. Now at this point, okay, at point B, what we find? IG and I minus IG both add to give you current I flowing out through B. Now, in order for this combination, okay, that is combination of galvanometer and shunt to be ammeter, the effective resistance of the combination must be very low. Why? Because ammeter must have very low resistance. So we need to show that this combination, okay, that is this combination behaves as ammeter so that the combination has very low resistance. So this is to be noted, okay. And what we find in this case is that S is very low resistance. That is, S is very, very less than the resistance of the galvanometer. So we have this. So we can think this circuit in this way also. Galvanometer having resistance Z. This is A, okay, this is B. And maximum current that can flow through galvanometer is IG. And remaining current I minus IG flows through shunt, okay. So we have this. So IG is flowing towards B and I minus IG is flowing towards B. So we know from Kirchhoff's first law, that is KCL, okay, sum of entering current at B equals sum of leaving current. So we find I current is leaving from B. So in this combination, current I is entering from A, okay. And this combination of G and S, current is entering from A and is leaving the combination from B. So we find this, okay. Now, what we find is that G is parallel to S. So therefore, potential difference across Z equals potential difference across S. So we find this I times G equals I minus IG times S. Therefore, S equals IG times Z divided by I minus IG. So let us call it equation 1. So this is equation 1. Now, the effective resistance of this combination. So I'm writing over here the effective resistance of the combination is, let's write in this way, okay, since galvanometer and shunt are parallel, okay, so we write in this way 1 by RA. Why RA? Because we are converting galvanometer into ammeter, so this is effective resistance, okay. So keep in mind this is effective resistance. So 1 by RA equals 1 by G plus 1 by S. Now what we find in case of parallel combination, okay, for parallel combination, okay, we find RA is less, this is RA is less than G, and RA is less than S. So we find this. Therefore, we can tell that, okay, we can tell the combination is, or combination have very low or negligible resistance. Therefore, or so, the combination behaves as ammeter having very low or negligible resistance. So this is how we convert galvanometer into ammeter. Now let us come to the question, okay? We are asked whether we can convert ammeter of range I less than Ig or not. So let us come to the question, okay? From question, okay, we have or given I less than Ig, and using equation 1, okay, S equals Ig times Z divided by I minus Ig. So when I is less than Ig, okay, I is less than Ig, then I'm rewriting equation 1 over here, then S is negative, which is not acceptable or is not possible, okay? We cannot have shunt negative, that is, we cannot have resistance negative. Therefore, if we have this condition, okay, I less than Ig, we cannot convert galvanometer into ammeter. So when I is less than Ig, we cannot convert galvanometer into ammeter. So we have this.